All right, continuing our discussion about reactions in aqueous solutions, the next topics to be discussed are down towards the end of the list here. We need to talk about using an activity series, how we predict whether a redox reaction will occur when a metal is placed in contact with a solution of an ion of a different metal, This takes some discussion, so here goes. If you're looking at this reaction where iron is placed in contact with copper ions to make iron 2 ions and copper metal, as shown in the diagrams at the top left and then visual photographs of the same process at the bottom, how do we know whether this iron nail will reduce copper 2 ions and become coated with a metallic copper? This requires the activity series of the elements. And then if you pick other possible combinations of metals and other metals ions and put them in solution, how do you know which one will occur or which one will not? How do you predict them? So can you take copper solid and mix it with silver ions? Or will it work, is that a possible reaction? Or do you have to take silver solid to react with copper ions? Only one of these is likely to work, and how we predict this is based on an activity series that no one will memorize, trust me, that allows us to make that prediction. Okay, so the activity series is a rather complex looking chart on this diagram here from your textbook. The partial activity series of the elements, apparently there's a lot more than we have that we don't include here, which is fine. And what we need to know is how on earth do you work with these things? So there's a few things to notice. The elements at the top are going to be strongly reducing. So the reducing agents, look at that. They're going to be group 1 and 2 metals in a general sense. They're reducing agents. That means they tend to lose an electron easily and provide them for something else. And then, reacting rapidly with things to release and make hydrogen gas. Reducing agents cause reduction of other things that need to gain an electron, so they provide an electron for other things. They're higher up in the table, they are likely to be oxidized. Think carefully, they are reducing agents. So the things at the bottom of the table are weakly reducing. They don't react with aqueous hydrogen ions, in other words, acids, to make hydrogen, and these are all described in terms of releasing hydrogen gas, but when reacting with another is relative reactivity. So an element higher in the activity series is going to reduce the ion of an element lower in the activity series. So the best reducing agents are at the top. And so we need to be able to use this and understand how it works to apply to predicting reactions. No one will memorize these, no kidding. That's entirely more complex than necessary here. So you have to look in terms of each element and how it gets, when you oxidize them, the oxidation reactions for each of them are shown here. Now also notice that some of these things will react with regular water to make reactions. This was described back in a previous chapter, but we didn't really have any context then. Sometimes you can react with hot water, in other words, or acid, hydrogen ions to make the reaction go. So the first set only requires water. It doesn't require acid necessarily, or, well, it can react with just liquid water, but the second one requires steam. In other words, it's got to be hotter. And then the other ones the next set is only going to react with acids. So the reactivity decreases as you go down. Notice that the things at the bottom are what we think about as noble metals, or things that are used for coins. Copper, silver, and gold have been used over time. Platinum, mercury is not so easy to work with, but each of those things are fairly stable. They don't tend to react with a whole lot of things. So it's kind of a contrast in reactivity that is notable here as we look at this. So what we have to look at is which things are more active or less active. The more active things tend to be the group 1 and 2 elements. The less active ones are going to be other transition elements. You can't predict them without the chart unless you've got a lot more information than we expect you to know in this course. So what we're looking at here is something like sodium reacting with water. Sodium will become oxidized. Its oxidation number goes from 0 to +1 while it reacts with water. In this case, the oxygen is unchanged, but the hydrogen is becoming reduced from +1 to 0 now that it's elemental hydrogen. And so sodium is getting oxidized. It is a good reducing agent. And hydrogen is actually also notably here going to be the oxidizer. Well, the water is. So oxidizing agent is the water. All right, so that fits with our generalization that group 1 metals are good reducing agents. They will get oxidized easily. All right, so taking a look at this pair of choices, the copper with silver ion or a silver with copper ion, which of these reactions will occur? So something higher in the series will reduce the ion of another element further down in the chart. So let's find copper. Where is copper? There we go. Here's copper. And then silver is even lower below it. Oh, they're adjacent, side by side. So if it's copper above silver, that means that copper will react with the silver ion, and this reaction does in fact occur. So copper reacts with silver ions to make copper +2 ions and solid silver. This reaction does not occur. NR, not going to happen. No reaction. And if you recall from what was done in class this week, I actually did the experiment where I put a piece of copper in a test tube and I added to it some silver nitrate. So here you have, this is effectively silver ions and being reacted with copper. And the result was very thick coating of silver on the copper. So you can tell that that reaction did in fact occur, creating the copper 2+ ions, which are in solution, and you can see the blue color reflecting their presence, indicating their presence. All right, let's take another one. So the silver cation, will oxidize the copper, becoming solid silver, and releasing or liberating copper 2 ions. Now, here's another comparison. Let's see, copper solid, copper metal with iron ions versus iron with copper ions. Copper 2 ions. Which of these reactions will occur? So we got to find them in the chart again. So copper is here and iron is here. Oh, so the one at the top is going to be the metal that reacts with the ion of the other. So the iron solid should react with the copper ion. In fact, this reaction should be the one that is evident, and the other one is not going to occur, not likely to occur. So what we're trying to do in each case is take an element and in some other a metal and then an ion of another element and see which possible pair of reactions is correct. So this in fact is another one of the demonstrations that was used in class this week, where I took an iron nail, and I added to it a solution of copper sulfate, and it didn't look very dramatic, but with time, eventually you would be able to notice the metallic copper on the nail as it has reacted with the iron. The iron is going to reduce the copper. So the iron is a better reducing agent than copper. Iron is reducing the copper to the copper metal. All right, so it goes from +2 oxidation state to 0. Remember that the iron at the same time is becoming oxidized, gets oxidized because it goes from 0 oxidation state to a +2 oxidation state. Increasing the oxidation number is, in fact, an oxidation process. If this reaction is done carefully, one can observe the presence of the color of copper being diminished in that reaction as it progresses, as the copper leaves solution and ends up deposited on the iron. Forward, advance the slide. There we go. Okay, now here's another possible set of combinations. What about zinc and hydrogen? Well, hydrogen is not a metal, but it's included in this series of reactions. Everything is compared to hydrogen, actually. And so let's figure out which of these pair of reactions will occur. Remember, you'll always have a chart like this for reference, or at least some fraction of it, to determine which reaction is going to occur. So zinc, let's find it. Up there's zinc, and then hydrogen is down here. And so it should be the one that's above that reacts as a metal with the ion of the other one. So zinc metal should react with hydrogen ions. And so in fact, reaction, the first choice here, this one will occur. And we should be able to see hydrogen gas evolved as a process, as a result. So the zinc goes from a 0 oxidation state to +2. The hydrogen goes from +1 to 0. And so the hydrogen is getting reduced because zinc is a better reducing agent. So zinc is the reducing agent because it's getting oxidized. Gets oxidized. So the second reaction on here does not occur. Not going to occur. Only one of these, not the other one. And so there we go. So the hydrogen could be equated to an oxidizing agent here. Oxidizing agent. There's always one of each. And it takes a minute to be careful to say which one is which. So perhaps you remember having seen this. The demonstration was done in class. I put zinc as in galvanized nail. A galvanized nail has coating of zinc. And I reacted it with HCl. And there was vigorous bubbling of hydrogen gas right away. And the process eats up, deteriorates the surface of the nail, making zinc ions and chloride ions. And this is where the chloride ions were already present. But zinc goes from +0 to +2, and the hydrogen ion goes from +1 to 0. Yeah, +0, nothing. We don't need a plus on there. So it's just 0. There we go. Okay, well, it doesn't let me take the charge off. All right, so that reaction was done in class also. If I had used a match, the hydrogen would have made a pop. No, yes, the chloride ion is still at a -1 oxidation state. It was a spectator in that process. Why is this so trapped under here? Gosh. Sorry for the delay. I meant to pause that. Apologies. Okay. The reaction we talked about a minute ago, the silver cation will oxidize copper, or the copper will reduce, copper will reduce the silver ion. We know that one works, becoming solid silver. Now, we're going to look at this diagram, the activity series, and see which of these reactions will occur. So let's look at the first choice, nickel and hydrogen. Well, here's nickel right there. And is it going to react with hydrogen ions? Aha, one has to be, the metal has to be above the ion in the series. So that looks good. Let's check with the other ones and verify whether they would work. So platinum with hydrogen. Platinum is down here, and hydrogen ions up here. Nope, that's not going to work. Platinum is particularly unreactive. It's why it's good to use for certain kinds of things, because it doesn't react with a lot. Including acids there. All right, the next one is tin ions and hydrogen. So let's look at the tin ions. Where's tin? Tin. There it is, tin ions and the hydrogen element. Okay, so is the element above the ion? No. so it's not going to work in this case. Look at another one. Let's look at the nickel and gold example. Nickel and gold. So nickel is already circled. And where is gold? And gold, we're looking at, but we're looking at nickel ions this time. So nickel ions reacting with gold. But as I noted earlier, gold is particularly unreactive, so that will not react. And then we'll look at the last choice, would be copper with zinc. Well, copper is already noted a little bit here, so let's find the zinc. So copper right here with zinc ions. Oh, the zinc ion is way too high above it in this reaction. So nope, only that one is the one that will occur for the set of choices. The nickel with the hydrogen ions. Here's another example that will take some discussion, and you may not like it because there's nothing filled in, but we could put in some pieces to recognize what's going on. Based on where they sit in the periodic table, you can make some predictions whether element A, B, or C reacts with the ions of these other compounds. So in a general sense, that things on this side are good reducing agents, and so they will reduce ions to metals. And so we're guessing that something like that would be a good reducing agent for substance B or C. And B or C may also be reducing agents, but not the strongest ones. And so let's see what our choices are. So A ion reacting with B metal should not likely. B ion reacting with C metal, that is really difficult to know based on the position in the periodic table. But in a general sense, we would expect it to go the other way, probably instead, both of these, more likely, because B is closer to the alkali metals than element C, so probably not. But what about the last one? A reacting with the ion of element C. Now that makes sense because it's a good reducing agent. A is a good reducing agent. It's likely to react with the ion of element C. So that one is the best choice on this. Now granted, you could put these in and identify them that A is in fact going to be magnesium. You could look it up. B is 1, 2, 3, 4, 5, 6 element across. That would be iron. And you could look it up and check it out. And then C is going to be something else unusual in there. Let's see, that would be platinum, I believe. And so you could check those and verify their likelihood of reactivity using the activity series. But this is a general idea of how you might make use of this kind of thing. Okay, this is enough of the recording for this, this topic. I hope these are helpful to you. Please read them carefully, ask more questions, and good luck on your homework. I'll see you in class.